Hello, it's Mrs. Scarple, and we're back to looking at solving systems using elimination. And in this system, we have negative 2x minus 5y equals 9, 3x plus 11y equals 4. Now when I look at this system, again, remember we want to have variable terms that have opposite values, opposite coefficients, so that they eliminate. So if I look at this system, I have negative 2x, positive 3x, opposite signs but not opposite values. I have negative 5y, positive 11y. Negative signs but not negative values. So the next thing I'm going to look at is, can I multiply one of the equations to form an opposite with the other equation? So I always look at the smaller values to see if I can multiply them to make the larger value. So starting with the negative 2, is there anything I can multiply with negative 2? And I'm thinking whole number. I don't like to work with decimals unless I absolutely have to. So is there a whole number I can take times negative 2 to get 3? And I don't believe there is. Is there a whole number I can take times 5 or negative 5 to make it the opposite of 11? And I don't believe there is either. So in this situation, we are actually going to need to multiply both equations. So we need to find a multiple of both coefficients in order to make this work for elimination. I'm going to look at the negative 2 and the 3. They're smaller numbers, and I know that 2 times 3 will give me 6. So I'm going to multiply the first equation, and again, remember, we multiply everything in the equation, times 3, and I'm going to multiply everything in the second equation by 2. Because when I multiply the two equations, my first equation will now be negative 6x minus 15y equals 27. My second equation, when I multiply everything by 2, will become 6x plus 22y equals 8. So now if we look at our system, we can see that the x terms are now opposite values. Negative 6 and positive 6 are opposite values. And they will eliminate. They will cancel each other out. So we can solve for y. Negative 15y plus 22y is 7y equals 27 plus 8 is 35. Divide both sides by 7. And we have y equals 5. And just like all of our other systems we've solved, we still need to go back and solve for x. I'm going to choose the second equation to use to solve for x just because right now everything is positive. So we have 3x plus 11 times 5 equals 4. So that's 3x plus 55 equals 4. I need to subtract 55 from each side. And we now have 3x equals negative 51. Divide both sides by 3. And we have x equals negative 17. So let's check to see if our solution of negative 17.5 is accurate. Is negative 2 times negative 17, subtract 5 times 5, going to equal 9. Well, negative 2 times negative 17 is a positive 34. Negative 5 times 5 is a negative 25. 34 minus 25 does equal 9. That is true. Let's check with the second equation. Is 3 times negative 17 plus 11 times 5 going to equal 4? That's negative 51 plus 55. That does equal 4. That is also true. So we have solved this correctly. The solution is negative 17.5. So now that we've looked at how to solve systems using elimination method, let's put this to an application. A business with 2 locations buys 7 large delivery vans and 5 small delivery vans. Location A receives 5 large vans and 2 small vans for a total cost of $235,000. So we have A has 5 large, 2 small for $235,000. Location B receives 2 large vans and 3 small vans for a total cost of $160,000. So B has 2 large, 3 small, $160,000. What is the cost of each type of van? So I'm going to identify my variables first, and I'm going to say let X equal the cost, because that's what we're solving for. We're being asked what is the cost. So let X equal the cost of a small van. And let Y equal the cost of a large van. And let's write our system. So for location A, if we're using these variables, we have 5 large, and I said Y would be large, so I have to write 5Y. 2 small, so plus 2X equals $235,000. Our second equation would be for location B, 2 large, so 2Y plus 3 small, so that's 3X, equals $160,000. So I have a system, I have my variable terms lined up, but I can see that I don't have any opposite values. And not only that, everything is positive. So when I multiply this, I am going to have to multiply something times a negative. I'm going to go ahead and decide to multiply the bottom equation by a negative, and I'm going to multiply the top equation by something that is positive. And again, let's go ahead and eliminate the y's this time. So I know that both 2 and 5 will go into 10, so if I multiply the top equation by 2 and I multiply the bottom equation by negative 5, that will make the y term in the first equation a positive 10y, and the y term on the bottom equation a negative 10y. So we can see we're going to have opposite y values. Let's finish multiplying through our equations. So 2 times 2x is 4x, and 2 times 235,000 is going to be 470,000. Negative 5 times 2y is the negative 10y. Negative 5 times 3x is negative 15x. Negative 5 times 160,000 Negative 5 times 160 is negative 800,000. So when I add the two equations together, right now the cost of the large vans is going to cancel out. So we're going to have negative 11x. So we're going to solve for the cost of a small van equals negative, because 800,000 is larger, 330,000 divide by negative 11, and a negative divided by a negative will give us a positive 30,000, and since x is the cost, we want a dollar sign on that. So x is 30,000 per small van. Now we need to find the cost of a large van. So I'm going to go ahead and use the second equation to help us find the cost of a large van, just because the numbers are smaller. So 2y plus 3 times 30,000 equals 160,000. So 2y plus 90,000 equals 160,000. Subtract the 90,000. We have 2y equals 70,000. Divide by 2. And y ends up being $35,000 per large van. So if we were to check that, is 5 times 35,000 plus 2 times 30,000 going to equal 235,000? So I'm going to use my calculator. 5 times 35,000 plus 2 times 30,000 does equal 235,000. That is true. We also need to check, does 2 times 35,000 plus 3 times 30,000, will that equal 160,000? Well, 2 times 35,000 is 70,000, 3 times 30,000 is 90,000, 70,000 plus 90,000 is 160,000. That is also true, so we have solved this problem correctly. The business pays $30,000 per small van, and they also pay $35,000 per large van.